Question number 5. The curve C has the equation ln x square plus k divided by x square plus k, where k is a positive constant. Show that dy by dx is this. We just need to apply the quotient rule. So I'm going to take the numerator as u, ln x square plus k, and find the derivative of u. By applying chain rule, I'm going to take this as x. So derivative of ln x is 1 over x times, differentiate the highlighted one, which is 2x over x square plus k. And then take the denominator as v. Derivative of v is 2x. Okay, now we have u dash v dash. We need to write dy by dx in this form. I'm going to apply the quotient rule now. Quotient rule is vu dash, which is x square plus k times 2x divided by x square plus k, minus uv dash 2x ln x square plus k divided by v square x square plus k whole square. You can cancel these two. So you have 2x minus 2x ln x square plus k divided by x square plus k whole square. We have the denominator same as the answer. In the numerator, we need to factorize it. So the common factor is 2x. You take 2x as a common factor out, you will get 1 minus ln x square plus k divided by x square plus k whole square. That's all. That's the answer. It exactly looks like this, where a is equal to 2, b is equal to 1. Let's move on to part B. Given that C has exactly 3 turning points, find the x coordinates of each point. Whenever they talk about turning point, we need to put dy by dx is equal to 0. So you have to put 2x times 1 minus ln x square plus k divided by x square plus k whole square is equal to 0, and solve for x. So bring this term here. So we'll get 2x times 1 minus ln x square plus k is equal to 0. Equate it to 0 separately. You'll get 2x is equal to 0. 1 minus ln x square plus k is equal to 0. So x is equal to 0. That's the first solution. And then ln x square plus k is equal to 1. Remove ln, the other side becomes e power 1. So x square is e minus k, x is plus or minus square root of e minus k. So whenever I get these solutions, 1, 2, 3 solutions, go back and read the question carefully, whether they mention anything about x. It's mentioned x is just a real number. It can be positive or negative or 0. So all 3 are the acceptable solution here. Now find the upper limit of k, part C. If you look at the answer, x is plus or minus square root of e minus k. If the k is bigger than e, you will get square root of a negative number. So the k has to be smaller than e, but it says k is positive, right? So k cannot be, k should be smaller than e, so that you will get square root of a positive number. So that's just a 1 mark question for part C. Question number 6. An area of seafloor is being monitored. The area of the seafloor, S km squared, covered by coral reef, is modeled by the equation S is equal to PQ power T. This is from chapter 5, exponential and logarithms, where P and Q are constants. T is the number of years after monitoring began. Given that you have an equation involving logarithmic function, find according to the model the area of the seafloor covered by coral reef when T is 2. Just sub in T is 2 is equal to, here make S as a subject. So log s to the base 10 is 4.5 minus 0.006 times 2. It's not natural logarithm, it's just a logarithm. So if you remove the logarithm, it becomes 10 power something. You need to remember this. Let's say ln x is equal to a. So x will be e power a because the base of this logarithm is e. But here the base is 10. So this becomes 10 power this. 10 to the power 4.5 minus 0.006 times 2. 30760 etc. round it to 3 significant figure, you will get 30800 kilometer square. That's the answer for part A. Let's move on to part B now. Find a complete equation for the model in this form. Okay, we have an equation log s to the base 10 is equal to 4.5 minus 0.0060. We need to get rid of the logarithm and write it in this form. It's easy, just straight away write s is equal to 10 to the power the whole thing. And then split it, you will get 10 to the power 4.5 times 10 to the power minus 0.006 t. We need p q power t, so you can write it as 10 power 4.5 times 10 to the power minus 0.006 to the power t. Does it look like p times q? But they want the p and q to 3 significant figure. So let's find p and q. 10 to the power 4.5 is 31600. So s is equal to 31600 times 10 to the power minus 0.006. Round it to 3 significant figure, 986. 0.986 to the power t. So p is equal to 31600, q is equal to 0.986. That's all. Part C now. With reference to the model, interpret the value of the constant q. This is q actually. So what's happening when the t takes 1, 2, 3 etc. We need to check actually. Okay, 10 to the power. In the previous part we got the value already, 0.986. 10 to the power minus 10 to the power negative 0.006. Okay. Now if you put this 0.986 power 2, it becomes 0.97 etc. If you put 0.986 power something else, a bigger number, the value is going down actually every year, right? That means what if this value is going down, the whole value is gonna go down. That's s actually. What is s here in this question? The area of the sea floor, the highlighted one, the area of the sea floor covered by coral reefs is reducing actually, decreasing. So how do you write it? Okay, you cannot just write the area of the sea floor covered by coral reef reduce each year, year to year, every year. You need to mention by what amount actually. So you say you have 10 to the power negative 0.006. If you change it to percentage, you get 98.6 percentage. From 100 it becomes 98.6 now, 1.4 percentage reduced, and the next year also the same. So you can say the sea floor covered by the coral reef reduces by 1.4 percentage each year. That's one way of answering. Let's move on to question number 7. We have a graph given. Find the range of f of x. If you look at the function, the range is the function takes the value from here all the way till here. So this is the y-intercept. You need to replace x by 0 to find the y-intercept into the function. So when you replace x by 0, it's f of 0 is equal to e power 0 is 1, 2 times 0, so minus 3 whole square is 9. So look at the graph, this is 9, this is 0, the function takes all the values from 0 to 9. So it's 0 to 9. Why I put less than or equal to? The graph touches the x-axis, so it takes the value 0 and takes the value 9 also. So that's the range. The range is 0 is less than or equal to f of x is less than or equal to 9. So easy 2 mark question. Part B, show that f dash of x is this. Okay, let's write f of x first. It's e power minus x square. Probably I'll do it here. We have the function. We need to apply product rule by taking this u and v. U is equal to e to the power minus x square. We apply chain rule by taking this as x. Derivative of e power x is the same. Differentiate the highlighted one. V is 2x square minus 3 whole square. Take this as x. We have x square. Derivative of x square is 2x times, differentiate the highlighted one. So we'll get 8x times 2x square minus 3. Now apply the product rule here. F dash of x is equal to, from f of x, keep the first function as it is. First function is e power x square. E power minus x square as it is times derivative of the second function, which is this 8x times this. 8x times 2x square minus 3 plus, keep the second function as it is, which is 2x square minus 3 whole square. That's the second function. Differentiate the first one, 2x e power minus x square. Now look at the answer. They want you to take 2x and e power minus x square as a common factor. Take 2x and e power minus x square as a common factor. There are two terms here. Don't get confused. There are two terms. Term 1, term 2. So when you take e power x square and 2x as a common factor, here it's 4 times 2x. So you will have 4 here in the first term, and then 2x square minus 3 plus 2x square minus 3 whole square in the second term. Now you need to take 2x minus 3 also, 2x square minus 3 also as a common factor. So 2x, I'm going to write it in the same format given in the question. So you will have 4 plus, here you will have power 1, 2x square minus 3. I think there is a slight mistake. When we differentiate, this becomes minus 2x actually. This becomes minus 2x. So here we will have minus 2x. So in this case, this becomes minus. This becomes here you will have minus of this. So 4 plus 3 becomes 7. The answer is going to be 2x square minus 3 e power minus x square. 4 plus 3 is 7 minus 2x square. So look at the answer. A is 7, B is 2. You don't need to write it as A and B. Just as long as you write this, that's fine. That's all. The next part says, given that line y is equal to k, intersect the curve at 2 points. Okay, I'm going to take the curve here. This is the curve. So you need to draw a line y is equal to k, which is going to be parallel to x-axis. But you need to draw a line in such a way that the line intersect the curve at 2 points. So you can draw here, 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 or here till this stationary point. If it goes below, it's more than 2 points. So you can draw anything between here, the stationary point, all the way to here, between these two lines, So we know the y coordinate is 9 here, so this line is y is equal to 9. If you draw this line, the line intersects at only one point. Okay, they are talking about y is equal to k, the line. They want you to find the value of k. K should be less than 9, so it can be anywhere here. Now we need to find the y coordinate of these two stationary points. When it comes to stationary points, we put dy by dx is equal to 0, right? We have calculated the dy by dx here in the previous part. We are going to equate it to 0. So 2x square minus 3 e power minus x square 7 minus 2x square is equal to 0. We need to put it separately equal to 0. 2x is 0, 2x square minus 3 is 0, e power minus x square is 0, 7 minus 2x square is 0. X is 0, that's the first stationary point. Look at the graph. The first stationary point is here. And then here x square is equal to 3 over 2. So x is equal to plus or minus square root of 3 over 2. E power minus infinity, x is infinity. So forget about this actually. Here x square is equal to 7 over 2. X is plus or minus square root of 7 over 2. I'm going to use my calculator to find the actual values of this, so we'll know which one represents which point. Square root of 3 over 2 is basically 1.2222. This is 1.2222. Square root of 7 over 2 is 1.8888 something. So if you look at the graph, this would be this point would be 1.8, this point would be 1.2, right? So we need this point. We need the y coordinate of this stationary point. So you take square root of 7 over 2, sub in into the function to find the x coordinate. Look at the function here. This is the function. So in this function, we are going to replace x by square root of 7 over 2 now. So this is a derivative. The function is here. So replace x by square root of 7 over 2. F of square root of 7 over 2 is equal to e power minus 7 over 2. The square root will be gone. 2 times 7 over 2 minus 3 whole square. This becomes 4 square is 16. So 16 e power minus 7 over 2 is the y coordinate of the point. So basically, if you draw a line here, its y is equal to 16 e power minus 7 over 2. So the k will be greater than this or less than line. That's all.